What you just saw is the final game we'll be building throughout this series. Now let's go back to where we left off. In the previous episode, we created a welcome screen for our Monster Battle Simulator. But right now, it's just text. To make this interactive, we will learn about data types, variables, and standard cin. But before we jump into that, we need to make two quick changes to our setup. First, if you're using CodeRunner in Visual Studio Code, make sure it's running your program in the terminal instead of the output window. That's because our game is about to accept user input, and the output window can't do that. Next, if you're coding on Windows, we need to add a tiny bit of code. Don't worry, you don't need to understand what it does just yet. We're only adding it so our game can display emojis correctly. Without it, you might see a bunch of weird characters instead. That's because the Windows command prompt doesn't use UTF-8 by default. If you're using Linux or Mac OS, you can skip this part since your terminal already supports UTF-8. Alright, as you can see, our game is now displaying correctly. Now let's start writing some code. The game needs to remember which monster the player chooses. So first, we need a place to store that choice. This line creates a variable called selectedMonster. Think of a variable as a container that stores value. In this case, we're using the int data type because the player will choose a number like 1, 2, 3, 4. So what exactly is a data type? A data type tells C++ what kind of value a variable can store. For example, int stores whole numbers like 1, 25, or 100. Double stores numbers with decimal points like 3.14 or 99.99. Char stores a single character like A or question mark. Let's visualize it. Let's imagine every data type has its own treasure chest. This is the int chest. The int chest only stores whole numbers lines. Let's try putting a slime with a value 5 inside. Perfect. It fits just fine. How about a slime with a value 10? That works too. Now let's try something different. A slime with a value 3.14. The int chest accepts it, but there's a catch. The chest only keeps the whole number. So the 0.14 part melts away, leaving only 3 inside the chest. That's why an int stores only whole numbers. Everything after the decimal point is discarded. Now let's look at the double chest. Unlike the int chest, a double chest can store both whole numbers and decimal numbers. A slime with a value 10 fits perfectly. A slime with a value 3.14 also fits perfectly. Nothing melts this time because double is designed to store decimal numbers. Finally, we have the char chest. This chest stores a single character like A, Z, or question mark. We'll use it later in the series. For our Monster Battle Simulator, the player will choose monster number 1, 2, 3, 4 since those are whole numbers and int is exactly what we need. So how do we let the player choose a monster? That's where the standard cin comes in. Standard cin is used to get input from the keyboard. When our program reaches this line, it pauses and waits for the player to type something. Whatever the player types is then stored inside our selectedMonster variable. You might be wondering what does this double greater sign mean? You can think of it as sending whatever the player typed into the variable. Alright, let's see if it works. I'll run the program. Notice the program is waiting. It is waiting because standard cin is asking us for an input. Let's say I want to choose monster number 3. Nothing happened. Did our program break? Actually, no. The value was successfully stored inside our selectedMonster variable. We just haven't displayed it yet. Let's use standard cout to print the value and make sure it was stored correctly. Now let's test it one more time. There it is. The program printed 3, which means our variable successfully stored the player's input. Right now, we're only printing the number. Let's make the output a little more user-friendly. You've already seen this part from the previous episode. This is called a string literal. It's just the text we want to display on the screen. After that, we use another double less than sign, followed by our variable selected monster. This tells C++ to print the value stored inside the variable right after the text. Let's run it one more time. Much better. We're not just printing text anymore. We're combining text with a value stored in a variable. And that's it. Our game can now receive input from the player and remember the selected monster. But there's one thing missing. Every monster deserves a name. The problem is, int only stores whole numbers. A monster's name isn't a number, it's text. So we'll use a data type called standard string. Before we can use it, we first need to include its header file, include string. Just like we included iostream to use standard cout and standard cin. You might be wondering, why didn't we have to do this for int? That's because int is a built-in data type. C++ already knows what an int is. Standard string is different. It comes from the C++ standard library, so we need to include its header before we can use it. This creates a variable called monster name. Unlike an int, which stores whole numbers, a standard string stores text. Alright, let's run it one last time. Awesome! We can now choose a monster and give it a name. Congratulations! Our Monster Battle Simulator is becoming more interactive with every episode. In the next episode, we'll make each monster choice actually matter. See you in the next one.